So everything that we're going to talk about today is all from the Stack Overflow database. If you go to brentozar.com/go/query stack, that's where you can go download the database. I want to make sure to credit that first because the nice folks over at Stack Overflow are so sweet in that they give us those databases totally for free to go play around with. I like these so much better than stuff like AdventureWorks or Northwind from Microsoft because these are relatively small sizes of objects. They're easy to understand. There's only like a dozen tables altogether. The joins are really straightforward. There's no convoluted stuff that's like trying to show off SQL Server's features. Everything that we're going to talk about today, if you want to reproduce the screenshots yourself, you can. I won't be working in Management Studio. I'm just going to be showing you screenshots as we go through this. But if you want to reproduce the screenshots, just make sure that you're on SQL Server 2022 or newer, or on Azure SQL DB, and on a recent compatibility level. We're going to be using printed handouts throughout this course. Now, I understand if you're working from home and you don't have a printer, that's okay. Go download these anyway. It's just a small PDF from brentozar.com/go/engine. Right at the top of the page, doesn't require a registration link. Having these pieces of paper in your hand is going to make or on your screen if you're just doing the PDFs, is going to make a world of difference in how you understand how SQL Server works. So take a second to go hit over there, brentozar.com/go/engine. Download that PDF right at the top. Have that ready to go over in Windows Explorer or Finder or whatever it is that you Linux people use. I support alternative lifestyles. brentozar.com/go/engine. All right, downloaded that yet? Got that downloaded? It's pretty quick and easy, fairly small. Off you go. So now we're going to start popping open the Stack Overflow database. We're going to go into the Stack Overflow database and we're going to go to the users table. The users table holds exactly what you think it holds. Everyone who's ever logged into Stack Overflow posted a question, posted an answer, and so forth. If we look at what's in the users table, it's a lot like a spreadsheet. If you look at the very first page in the PDFs, it looks like this. The first page of the PDFs looks like this. This is the clustered index of the users table. The clustered index we kind of think of as the table itself. The table itself is sorted by ID only because when we designed this table, I'm going to go back a slide and look at the PowerPoint or the SQL Server Management Studio. You see the little ID up there. You see the little ID up there, primary key that's got the little key next to it. That defines how the table is sorted. Over on the far left-hand side, you'll see ID starts at 1 and goes up to a bajillion here. We like to say that the clustered index has all of the columns on it, whether you like it or not. That's not exactly true. If you look over at the far right-hand side of your PDF, you'll see the About Me column. Stack Overflow, they let you write a letter to grandma in the About Me column if you want. You can put all kinds of stuff in there. When I was young, my father invented the question mark, or whatever it is that you want to put inside there. That big old column is an nvarchar max. You can also do similar with varchar max or XML or JSON. These objects may be too large to fit on one page. See, in SQL Server, these pages are 8 kilobytes. 8 kilobytes! How tiny does that sound? SQL Server is trying to cram as many rows as it can on these 8 kilobyte pages. And your About Me may be way larger than what fits on one 8K page. So SQL Server actually puts pointers over to other pages and daisy chains them together in order to stuff your big old nvarchar max or varchar max or JSON or XML type data. We're not going to be talking about this kind of off-row data today. We're going to be focusing on more normal data types. But I just want to give you that heads up that when you do big old data types like nvarchar max, varchar max, JSON, XML, there's a storage cost to that, but also there's a query processing cost to that. We got to jump around to other 8K pages in order to get that stuff that you're looking for. Everything in SQL Server, well, almost everything, is arranged in just a bunch of 8K pages. If you think about your database's data file, it's just a bunch of 8K pages that are all lined up in a row. Each 8K page has stuff for just one table on it or just one index. SQL Server doesn't work in rows or columns or tuples. SQL Server works in 8K pages. This is the smallest unit of data that we're going to either read or write. It's these same 8K pages that are on disk, same 8K pages that we have up in memory. For example, if I want to make a change to someone's display name, I got to get their 8K page up in memory, I got to change it, and then I got to scribble it back down onto disk. SQL Server does a ton of I/O in this format. When you write a query, in a perfect world, your select query is really easy to understand. SQL Server could look at your query and go, oh, I know exactly what you're looking for. I know exactly where it's stored in the database. I know exactly how to dive in and get it. You're only asking for a couple of rows, so SQL Server is going to dive straight into that area, grab those rows, and hand them right back out to you. In a perfect world like that, our access to go get the data that we want looks really simple. We're just going to dive into one area of the table, and everything that we have is ready to go there. Well, that's a perfect world, but that's not the world that you and I live in. In the world that you and I live in, people are writing queries like they're monkeys with typewriters. They're asking for stuff scattered all over the database. SQL Server can't predict which pages their data is on. We don't have those 8K pages cached up in memory because your boss got cheap in terms of storage. Then SQL Server has to do a bunch of grouping and joining and sorting because you've joined 32 tables together. In a world like that, we're going all through the whole database, looking at all these 8K pages, trying to find the data that we want. There's no magic to this. Our work, when we go to think like the engine, is we got to figure out where the data is, how we're going to get it, how many rows are going to come back, which copies of the data we're going to process first, whether we should get multiple cores involved, how much memory we should get involved. We're going to be building execution plans over the course of the next couple of hours. And when I say we, I mean you. Your job in the next couple of hours is to be SQL Server. Your job is going to be to come up with an execution plan. But I want you to do it in plain English. See that PDF that you have that has the white pages in it? And for those of you who are joined late, it's there on the screen. The links for everything that we're talking about here, the slide decks, all that stuff is over there. Often people will say, well, I'd build a doubly linked list. I'd build a sorted B tree. No. You are just a human being with a stack of these pieces of paper in front of you. And when I say you're going to build an execution plan, I want you to tell me in plain English how you're going to accomplish the query. This is the first query that we're going to start with. Say my query is select ID from DBO users. There's no where clause. There's no order by. Some of you are not very bright, so I have to start with a really, really simple query. How do you execute this query in plain English? Well, in plain English, you're just going to go grab the first piece of paper and you're going to start reading through the rows. You're going to grab the first piece of paper off of the stack and you're just going to start yelling out the IDs. 1, 2, 3, 4, 535, 536, 537, and so forth. That's our execution plan in plain English. Now let's see how SQL Server accomplishes that same goal. We're going to run our query and we're going to turn on actual execution plans. This is totally safe to do in Management Studio. You can run queries with actual execution plans turned on. It only affects your own session, doesn't add any real overhead there, and it's a really good way to understand what SQL Server is doing. The way that we read these execution plans is we read from right to left. We read in the direction that the arrows flow. You see the little arrow over there, over at the middle, the gray one, not this one right here, the one big one over there. So the data is pushing through this way. The first thing that SQL Server did was a clustered index scan, because right now this is the only copy of the data that we have. We haven't added any indexes or anything yet. So SQL Server is going to do this clustered index scan. And I adore these little icons. These little icons are so good because they really explain to you what SQL Server is doing. SQL Server is starting at one end of the stack of paper and reading until it has enough rows to justify what you're looking for. So how much is it going to read? How much work is this query? One way to understand how much work a query is to turn on this option called Set Statistics IO On. Set Statistics IO On only affects your own session, and it brings back all kinds of data. The one you care about, the one piece of data you care about, is logical reads. Logical reads is the number of 8K pieces of paper that SQL Server had to read through. Now, granted, they're not paper, they're stored on disk, but the number of 8K pages that SQL Server had to read in order to accomplish your query. In this example, SQL Server had to read about 7,000 pages. That's about 15 reams worth of paper. You know how when you used to go into the office, there would be those reams of paper over by the copy machine? It'd be a big old wad of paper. It's got 500 pages in it. As we're doing this work, as you're building execution plans, I want you to think about having a stack of 15 of these next to your desk, or maybe over in an office supply closet. This is one of the smallest tables at Stack Overflow. This is a tiny version of the Stack Overflow database. And yet 7,405 pages, we're going to have some work to do as we go through and execute these queries. So let's start to make the query a little bit more complicated. Let's add a where clause to it. Show me the IDs of the users whose last access date, that column means exactly what you think it means. It's a list of a time when the person last logged into Stack Overflow, touched a page, accessed the site. Show me everyone who's accessed the system since July the 1st of 2014. How are you going to execute this query in plain English? I'm going to let you come up with that answer over in YouTube chat while I take a sip of my tasty beverage. I live basically on coffee, caffeine-free Diet Coke, and sugar-free Red Bull. Those are basically also Gatorade Zero. After I'm hungover, I drink a lot of Gatorade Zero the next day. That's my homemade remedy. Donald says use an index. Wouldn't that be cool if when we had lazy, incompetent developers and database administrators, if we had human beings who were just sitting around with their hands in their pockets, wouldn't it be cool if the database automatically created indexes for you? Unfortunately, that is not the world we live in, Donald. This system's database administrator, aka you, has not given you any indexes. This is the only object that we have. So So Picard says, read the entire stack and only call out the IDs for the rows which happen to fit into the date range. Hero Rolex or Rolex or Relax says, I'm going to read all of the last access dates and memorize the IDs that respect the condition. Hero, here's the thing. I don't think you're that bright. I don't think you're going to memorize that many numbers. I don't have that much confidence in you. I think what you're going to do is what Picard said first. You're going to go through all of the pages. You're just going to pick up the first page, and you're going to check each person's last access date, and then you're going to say the rows out loud for the IDs that match. The nice part is you don't have to write them down. You don't have to memorize them. You don't have to remember them from anything. Literally, the instant that you see a row that matches, you can yell it out. You can shove it down the network cable. Take that ID. And you don't have to remember anything. So here's how SQL Server's execution plan looks. We got a couple icons in here now. We read from right to left, top to bottom. The first thing that SQL Server did is this clustered index scan, but you notice there's something different about this one. This one has that little racing icons, as Eric Darling likes to say, racing stripes on here, meaning that this query went parallel, or this task went parallel, across several CPU cores. Well, why'd this one go parallel? The last one actually read the same number of pages, and it yelled out more rows. Let's jump back a couple of slides. When we didn't have a where clause, it didn't go parallel. Well, the fact that we read every row out of here, that we didn't have a where clause, what that means is SQL Server could grab the first piece of paper and it didn't even need to look at anything. It just starts yelling, 1, 2, 3, 4, 5. It could immediately start yelling out IDs through this little arrow here, and it could keep the application busy on the other end of the pipe. Whereas now that we have greater than last access date greater than July of 2014, now, as we're reading through here, we're not going to yell out every ID. So we could actually get several of our friends in here to all go through these 15 reams of paper. We could get all of you who are attending this webcast, here, you go take a stack of paper, you go take a stack of paper, and you're reading through, 14, 72. You could read through and you wouldn't keep the app as busy on the other end because not as much of the data is going to match. One of the things that I love about SQL Server, I love a lot about SQL Server, but one of the things that I love is that it'll automatically parallelize work in situations like this. It's not that it read less data. If we look at statistics.io, the first one with no where clause, we read about 7,400 sheets of paper. In the one with the where clause, when we got parallelism involved, we actually ended up reading a little bit more of the pages because we had to work a little bit to synchronize everybody's pages across, make sure we don't double hand out pages as we go through the wild and crazy parallelism stuff. One of your first takeaways in here is that just because you have a where clause and you're returning less rows doesn't mean you're scanning less data. And in fact, you may actually be scanning more data or reading more 8K pages, especially in the case of this thing going parallel. If I look and compare these two execution plans, the one with the without the where clause and the one with the where clause, if I want to compare to see which one's more expensive, what I can do is hover my mouse over the select icon and I'll get a number called estimated subtree query cost. Estimated subtree query cost. This estimated subtree query cost is if you go through and add up across all of these little icons how much CPU and I/O work that SQL Server thought was going to be performed, that gives you a rough estimate of estimated subtree cost. Now, a long time ago in a galaxy far, far away, when people at Microsoft were actually sitting around building SQL Server, they built this cost-based optimizer. A long time ago, the legend has it that if a query took 5 seconds, it would have an estimated subtree cost of 5. If a query took 30 seconds, it would have an estimated subtree cost of 30. Those days are long gone now. Those numbers have nothing to do with time whatsoever. Sometimes you'll see documentation that says it has to do with seconds. It absolutely does not. And to drive that point home, Kendra Little, an active blogger in the community, coined this term called query bucks, the estimated subtree cost of, say, 30 query bucks or 50 query bucks. And so you'll hear me use that all the time, too, when I'm looking at subtree costs, saying this query cost about 100 query bucks. It's just an estimate from Microsoft about roughly how big the query is, and it's often wrong. Just like with your project managers, when your management asks the project manager, hey, how long do you think this thing is going to take? And the project manager's like, 2 weeks? 6 minutes? They're just making that number up, just like estimated query bucks. Coda says, isn't a query buck like CPU plus some other measurement unit? Yeah, Coda, it's almost as if you read what was on the screen. Not quite. I mean, we can both tell that you didn't actually read it. But it's almost as if you looked at the things that were up there in really big print that told you that it's a measure of CPU work and I/O work required. Yeah, about that. All right, let's make the query a little bit harder. Let's add a sort. Show me the IDs where the last access date is greater than 7/1 of 2014, and I want you to order them by last access date. Now things are gonna get harder. You have a stack of 7,400 of these pieces of paper. You have 15 reams of these pieces of paper. How are you going to access this? Go. Let's see what you've got as your execution plan over there in plain English. Don't tell me things like, I want to build a doubly linked list. Tell me, as a human being, how would you execute this query and return those results? Let's see what you've got. Simon says, long time no see. Hope you're doing well. I'm doing quite well. Double says, this is the worst date format out there. Yeah, okay, all right. We'll see how that goes. Hero says, it's same as previously, but now I'm going to write the IDs down. Okay, this gets a little tricky. What are you going to write down? You can't just write down the IDs. If you only wrote down the IDs, then as each ID comes in, as each new ID matches, how do you know where to put it in the list? You got to be able to sort them as you go or afterwards. Either way, it doesn't really matter to me in terms of project management. But you're going to have to write down two things. You're going to have to write down the ID, and you're going to have to write down its last access date, so that as you're sorting them, you'll be able to sort them out by last access dates. Okay, there's SQL Server's execution plan. So now you notice we got an extra operator in here. We got this clustered index scan. I think of each of these little operators as like a standalone microservice. These only do so many things. And Microsoft wrote SQL Server in a way that it could plug different operators in at different spots in the plan. So the sort's going to happen later. The first thing we're going to do is scan the clustered index. And you think of that little arrow as like a yelled list of IDs and last access dates. 14 on July the 1st, 17 on July 21st. It's just going to be yelling out IDs and last access dates as fast as it can scan through this table. Then it's going to turn around and sort that data. So how does that execution plan look? Compare, the first one was just the where clause, no order by. Second one, now that we have a sort, our cost is up by a lot. The estimated cost when we didn't have an order by was about 6 query bucks. Now that we've added in that sort, our sort has more than doubled the cost of the query. Plus, there's something new inside here. A memory grant. See, we're going to need, I don't know about you, but I'm not very bright and I drink a lot. So I'm not going to be able to write, I'm not going to memorize all of the IDs and last access dates. I'm going to need some memory, and that's where the memory grant comes in. Now, as I'm discussing this, I always use little moleskin notebooks in order to display it, but I should point out that when SQL Server does these memory grants, it's actually the same 8K pages. It's the same unit of measure. SQL Server's building its own tables on the fly, so to speak. Don't be distracted by the fact that this is smaller than this one. If you want to see more about what's going on with those memory grants, you can right-click on the select operator, go into properties, and there's all kinds of interesting details in there around memory. These numbers are all measured in kilobytes because why in God's name would Microsoft use the same numbers everywhere? Why is it that they would always use 8K pages, or they would always use kilobytes, or always use megabytes? I swear to God, it's like they're purposely trying to make your job challenging, thus paying me a very good living for training, which I should not complain too loudly about. So SQL Server said, I desire 14 megabytes of memory. I am going to request 14 megabytes worth of memory. After waiting a period of time, 0 milliseconds in this case, I got granted all 14 megabytes worth of memory, and I used about 8 megabytes worth of memory. One of the things that I find really interesting about databases is that SQL Server has to come up with all of these grants before the query even starts. It's not allowed to look at the contents of the database. It's allowed to look at statistics. More on that later. But it doesn't adjust this memory either. Once your query starts running, any one query by default can get up to 25% of the server's RAM. I'm going to say that again because it's really interesting. Any one query can get up to 25% of SQL Server's RAM. It doesn't take a whole lot of 25% before you're screwed and other queries can't even start. And when queries can't get enough memory to do what they want, you end up seeing little yellow bangs over their sort operator saying, warning, I needed to write tempdb to spill data. I ran out of pages up in memory, so I had to write that stuff down into tempdb. This is one of the many reasons, not a few, but many reasons, that your queries can be so fast in development where there's no competition for memory because no one else is running queries at the same time. And then they fall apart and catch fire over in production because so many other people are running queries at the same time. All right, let's change something about the query. Instead of just doing select ID, let's do select star. Does this change the way that we execute that query? I know when I was a developer, I used to think, well, what SQL Server should do is it should only write down ID and last access date. And then after it gets done sorting stuff, then it should go back to the table and get all these other columns that people are asking for. But that's not what SQL Server does. SQL Server wants to get you in and out of the table as fast as it possibly can. You're not the only person who's asking for data from this table. If you were trying to do this back and forth lookup stuff between your work pad and going back and getting your data, if you were going to do that back and forth, you would have to hold on to locks the whole time this was happening. SQL Server says, nope, ain't nobody got time for that. If you want to be dumb and you want to go get select star, we're just going to write down all of the columns. I don't know that it's really a problem with SQL Server, but it's more of a problem with our query. But why does it suck? Why do people get so amped up about how bad select star is? Let's break this down into pieces. Do we work harder to read the data? And I'm going to rephrase this to say, will we read more 8K pages? Will we read more 8K pages when people do a select star? I'll give you a second to think about it. Put your answer over there over into chat. Are we going to read more 8K pages? Some people say yes, some people say no. Grab your 8K piece of paper and look at the right-hand side. Remember that about me that I said in the beginning? If you had big ol' about me's, it would actually be pointers to other 8K pages. Now we have to read those. If you ask for that other stuff that we didn't need before, now we actually have to read more 8K pages. Now, it's going to depend heavily on how big people talked in that about me, but the more that they wrote in there about me that we didn't need before, now we're going to have to read more pages. Do we work harder to write the data? Oh, hell yeah. This is going to be a giant stack of paper now because we have to write down ID, display name, last access date, about me, reputation, every single column on the table. Do we work harder to sort the data? The developer in me says no, because it's the same number of rows. But the reality is that because this stack of paper, our scratch pad is so much higher, that's more data that we have to shuffle in and out of our cache, more CPU work that's involved. So it ends up being more work for sorting as well. And then, do we work harder to output the data? This used to be the part that I would focus on as a database administrator. I'd say things like, don't return columns you don't need because it takes longer to say it over the network. That's true. It's just pretty much the least of our problems. The biggest part of our problem is this fella right here that is now 97% of the cost of the query, and it's 97% of a much larger number. The query cost has absolutely exploded. The memory grant has absolutely exploded. Or to put it all on one slide, holy ShamWow. I don't care if you do select star. If you want to do select star, like if you're saying select star from a table where ID equals 1, 2, 3, 4, 5, sure, that's fine. I understand that you've got to paint a user's profile screen and you've got to get all the columns for their profile screen, or one particular product, you need all the attributes of that product. But if you're going to put in here more columns and more tables, more joins, more rows, this gets expensive. And part of the problem that sucks with this is you never run a query just once. No one can eat just one, as Bill Gates famously said. I think it was Bill Gates. Might have been Mr. Peanut. I'm not exactly sure. You can put in a number after the go statement in Management Studio, and that tells Management Studio to run the query a number of times. This is really useful if you want to do a denial of service attack against production right before you go to lunch. What you would hope would happen is that you would read through the table, writing down all of the columns, and then you would hang on to this for a second, so that you could reuse it the next time you saw the query. Some databases do. That's also part of the reason that Larry Ellison is so wealthy that he owns an entire Hawaiian island. Larry Ellison is so wealthy that he can afford to use your licensing revenue to go sailing. He does America's Cup sailboat racing, and I have a lot of Team Oracle gear because I like their sailing teams. Microsoft, on the other hand, they don't want to take all of your money and spend it on Hawaiian Islands and sailboat racing. Instead, what Microsoft does is they cut the prices and they pass those savings on to you. And by pass the savings, I mean they push the CPU work onto your CPUs. SQL Server only caches data pages. SQL Server does not cache query output. It doesn't matter if no one else has run an insert, update, or delete. It doesn't matter if no one else has run any queries. It doesn't even matter if you're on a read-only replica or if the database is marked as read-only. It doesn't matter if 10 of you run the same query at the same time. SQL Server rolls up its sleeves and executes the query, building your result sets and sorting them every single time. So what have we learned so far? What you've learned so far is that set statistics IO on is a really good way to measure how many 8K pages your query has read. Generally speaking, the less pages that your query reads, the faster it's going to go. That's not the only way to measure queries. I'm going to show you another one in the next module as well. If you have a where clause without a copy of the table to support it, you're going to be doing a table scan. If you have an order by without a supporting index, that means doing a lot of CPU work. What you're going to learn next is how SQL Server uses non-clustered indexes when we create them and the differences between seeks and scans. Now, some of you are going to need to leave. Some of you are going to go, oh my God, I have already learned something in the first half an hour. I thought I was so smart, but it turns out I didn't even know the first part of the first free class that Brent Ozar teaches. No problem. If you need to come back, go to brentozar.com/go/engine, where this entire class is totally free. And I've got both written versions and video versions. There are resource links throughout. And then after that, you can step up to my Fundamentals of Index Tuning class, where I teach you how to design indexes for queries without even looking at the execution plan. I demystify how SQL Server suggests missing indexes. I show you where those hints come from and why they're usually wrong. I give you hands-on assignments so that you can see that you actually learned the stuff that we covered in the class, and then the next class goes into query tuning. Now, good news. The people who are in here, let's see how many we got now. 324. The 324 of y'all who are in here because it's free, because your company is cheapskates. They will not pay for your education. Good news, I am teaching Fundamentals of Index Tuning and Query Tuning October 13th through 16th for free. I'm teaching the first half of each of those classes, plus my classes on Column Store and TempDB, totally for free. All you have to do is show up and be reasonably caffeinated so that you can pay attention. Those will not be streamed on YouTube. If you want to attend those, you're going to have to register. You're going to have to give the evil spam meister Brent your email address. So you're going to go to brentozar.com/go/funweek and register there. You'll get calendar reminders so that you can show up for class online. This is only live on those dates at those times. If you can't attend, you can buy the classes. You can buy the class recordings over at brentozar.com/go/early Black Friday. During Black Friday, all November long, I run a sale on my fundamentals classes and my mastering classes. On Black Friday, it's actually going to be $295, but if you want to get in today, you can get in today over at that Go Early Black Friday link, where you get the whole classes that we're teaching on Fundamentals Week, plus additional classes as well, and you get the whole classes, the ability to follow along with the labs, do the live class attendee chat stuff too as well. Come on down, brentozar.com/go/early Black Friday. Now, Vedichin says, for this first free week, do you have a guarantee of a fun week? Absolutely. If you don't have fun that week, I will give you your money back. All of it. All you have to do is send me $20 for shipping and handling, and I will send you all the money you paid for free. Can you believe that? What a deal. All right, let's go back to the class. I love my job. All right, now let's add on an index. Go back to your PDF. And in the second page of your PDF, There's a black page. This black page is what results when you create this index. I'm going to create an index on last access date and ID. When you create an index, SQL Server literally makes another copy of the table. Every row in here is going to have another row in here. So the first thing that you'll notice then is this is two copies that are stored on disk, two copies that may be competing for the same memory. This is two copies of the table. Your database is going to get larger. A non-clustered index is a copy of the table where you get to choose which columns it's on. Clustered index, you don't get that choice. Clustered index has all of the contents of the table. We think of the clustered index as the table itself. Non-clustered indexes are really like reporting copies of the table. Well, because we have two copies of the table, that means that every delete and every insert has to do twice as much work. We are kind of doing a denial of service attack against our own storage. Every time we add a row, every time we delete a row, we've now doubled the amount of work that our storage has to do. It's not necessarily the case with updates, though. Updates only affect the copy of the table that has the rows that are, has the columns that are being updated. For example, let's say that I get 1 year older. Say that I update the users table to set my age equals age plus 1. I still only have to do 1 right here because age is only stored on the clustered index. I didn't put it on my non-clustered index. Part of the cost of bigger and better indexes is that they can also affect your update statements. This is why, in theory, we don't want to update very hot columns, columns that change. I'm sorry, I said we don't want to update. That's not what I meant. We don't want to index very hot columns, columns that update all the time, quantity in stock, customer balance, and so forth. Lucas says, why would you store age in a database? Lucas, the database is public. Lucas, do you really want the public copy of the database to include everyone's birth dates? Lucas, do you want to get hacked? Because that's how you get hacked. If you publicly share your users' birth dates. Lucas, you gotta realize that your microphone is on. It's on, Louis. When you type, your words are right next to your name. Think about that, Lucas. Assuming that is your real name. So in theory, you don't want to index very hot columns. You don't want to index columns that change all the time. Customer balance, quantity in stock, and so forth. In theory, I want to have just enough indexes so that my application goes fast, but not so many indexes that it slows down my inserts, updates, and deletes. So let's go back to our select query. Here was our query. I'm going to go back to just the ID. Show me the IDs of the users where last access date is greater than July the 1st of 2014. Now, how do we go about executing that query? Well, now that we have this black copy of the table, now it starts to make a lot more sense that we're going to be able to dive directly into one particular last access date. Now, here's the thing. In order to teach you as much as I can within the confines of like 3 hours, I got to leave some stuff on the cutting room floor. SQL Server has a structure called a B tree where it can jump directly to the page that has July the 1st of 2014. In an index, like a non-clustered index, there's kind of like a directory that shows which data is on which pages. I'm not displaying those here, and honestly, you don't need to know how those work. as long as you understand that when SQL Server has an index on, say, last access date, it can dive into one particular last access date. You're going to be good. Your biggest goal when you're working with indexes is just understand what to put on the page. Once you understand what to put on the page, then things get a lot easier. So how does SQL Server's execution plan look? Well, you notice it's gotten way simpler now. We're down now back just to one smooth operator. We only have one operator on the page here, and this one operator does everything that we need to have done. Notice that the little icon is different too. Instead of it going from one end of the I always love this. I'm real easily amused. That always never gets old to me. SQL Server now, instead of going to one end of the table and scanning back the whole entire way, SQL Server is able to dive into one particular area of the table. It's doing an index seek. It's seeking directly to one area of the index because the data is organized by last access date. This is also really cheap. Our estimated subtree cost has absolutely plummeted. And it doesn't matter whether we're doing a selective ID or whether we're doing select star, our costs have absolutely plummeted for this query. So why is this query cheaper? Why is the query buck cost so much lower? Well, you remember I said that there were two parts to query bucks. One was CPU and one was I/O. It's kind of intuitive that indexes help you read less data. If I compare these two queries, the top one says with index equals 1, which means the clustered index of the table. I am forcing SQL Server to scan the entire table like it did before it had the index. Before the days of the index, we read about 8,000 logical reads, about 8,000 pieces of paper. But then when we have the index and we let SQL Server choose it, it reads way less data because it's able to dive, not dive bomb. Thank you, Anand, for noticing that I'm doing such a good job on that. It's able to dive directly into this one area of the table that just has the data that we need. Reading less data is the intuitive part of indexes. Using less CPU is the other unintuitive part of indexes. Notice way over there at the top, I've turned on another option here, Set Statistics Time On. Set Statistics Time On shows you how much CPU time you burned executing that query. And in theory, the easier that I make my computers work for building a query, the less CPU time that I use, the less my licensing costs are going to be. And before, when I had to sort the result sets, we were talking about 189 milliseconds worth of CPU. Now that the data is already sorted, the CPU time has plummeted as well. This index is called a covering index because it covers everything that our query needs. The index is sorted in exactly the right way where we can dive into just the rows that we want. And it's also sorted in a way that we can read the data right out, and it's already pre-baked in the order that our query needs it. But if we change anything about that query, the index may no longer be covering. Just one thing to point out there. Sometimes when people see this course, they think index seeks must be magically delicious, that a seek means things are going really well. That is not what it means. Seek sounds really small and lightweight. Seek sounds like I'm just going to dive into one portion of the table and only read out a handful of rows. That is not what's happening here. We're pulling back like 150,000 rows. Seek does not mean I'm going to jump to one row and read that row, nor does scan mean you're going to read the whole entire thing. That's counterintuitive because the word scan makes it sound like you're going to read the whole entire thing. Seek makes it sound like you're just going to read one specific row. But to prove it, let's change the date we're looking for here. Let's look for everyone who's accessed the system since January of 1800. Pro tip, Stack Overflow was not around in the days of covered wagons. But that still ends up being a seek, because SQL Server can't guarantee that nobody accessed the system before then, even though there are things like statistics that help SQL Server understand where our data is at. That doesn't mean that SQL Server can guarantee that it's going to read the whole table. What seek really means, excuse me, what seek really means is that we're going to jump to one particular row and start reading there. But you can seek to the very first row of a table and read the whole entire thing. That's exactly what's happening here. SQL Server is seeking to the first row and then reading the whole entire table. There are bad seeks. Scan only means I'm either going to start at the first piece of paper or the last piece of paper, and I'm going to read until I find enough rows to finish my query. There are great scans. I'll give you an example. Select the top 10 stars from DBO users. There's no where clause. There's no order by. All SQL Server is going to do is go stumble over to the stack of pieces of paper, grab the first one, and go, attention, user ID number 1, reputation of 2406, name Jeff Atwood. Is just going to go through, read the first 10 rows, and bail. You can't make that query go faster with an index. That is a perfect scan. Seek doesn't mean good. Scan doesn't mean bad. There are bad seeks and there are good scans. I don't want you to think when you're looking at an execution plan that as long as you've got seeks all over the place, we're done. Okay, so now we've got indexes in place. We've learned that indexes are literally a copy of the table. Although with non-clustered indexes, you get to pick and choose which columns are on it. The good thing about indexes is that they help selects go faster. The more copies of your data that you have that are organized in the ways that people that want to query them, generally the faster your selects are going to go. However, the more copies of your table that you have, the more inserts, updates, and deletes start to suck. It takes longer to do those inserts, updates, and deletes, and you can start running into blocking problems. Seek just means that you're going to jump to one part of the table and start reading. It doesn't define how many rows you're going to read. Scan just means that we're going to start at either end of the index. SQL Server can do forward scans or backward scans. SQL Server scanning doesn't necessarily mean that we're reading the whole table. What you're going to learn next is more advanced portions of how executions are built, how SQL Server uses statistics, how it has a tipping point about when it makes sense to do seeks and scans and so forth. All right, let's go back to just getting the IDs. Get me the IDs from the users table where last access date is greater than July the 1st, ordered by last access date. When we had this table, or when we had this query, we were able to dive into one particular area of the table, begin reading, and everything was already ready to go for us. Let's change this query. Let's add a couple of columns. Let's add display name and age. Display name and age are not on this index. So how are we going to build this execution plan? I'll give you a second to think about it while I have a sip of my tasty beverage. Oops, got to put some things down here. I can't hold everything. Let's see what y'all come up with there in chat for your execution plan. Do 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 do. Do 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 bomb bomb. No one one has an idea yet, that's okay. This is called compilation time. SQL Server takes compilation time too. And the harder that your query is, the more complex your query is, the longer your query takes to compile. The harder it is for SQL Server to build an execution plan. The more joins that you have, the more indexes that you have in your objects, and so forth. So one way that you could do it is you could grab your index, go seek in to July the 1st of 2014. You could write down the ID and last access date of your matching records. Then, after you'd found them, you could go over here and hit the key lookups to go look them up by ID. Like what Steven says, my friend says, just, change the indexes. Wouldn't it be cool if SQL Server's Query Optimizer could just change your indexes on the fly there, Steven? I love the idea. I wish I could live in the world that you're in. Back here in the world that we live in, SQL Server does not build indexes on the fly, and it is cursed with your incompetent index designs, and that's why we're all here, is I'm trying to make it better for you so you stop sitting around hoping that the little short trolls inside of SQL Server are going to do some kind of magical work for you. The only kind of magical work that's happening here is those mushrooms that you're on. You have to do some work here. It's up to you to fix this problem. So this is one way that it could happen. SQL Server could go through and look up these by row in order to get their display name and age. So now what we have here is we have our first kind of stacked execution plan. I said for so far we go read from right to left, top to bottom. Now we actually have a top and a bottom here. So the first thing the SQL Server did, the top right thing, is it seeked in on the index, read out the rows that matched, wrote them down, and for every one that it found, it looked it up by the key in order to get those additional columns. I lied to you. Early on, when I explained how this index thing worked, early on, I told you that I created this index on last access date and ID. I didn't have to do that. I could have just created my index on last access date. SQL Server will automatically add the IDs whether I ask for them or not. The reason why is that for every row on this index, if we go find someone by last access date, I got to be able to uniquely identify them over on the clustered index. I got to be able to join from this thing over to this thing. So SQL Server automatically includes the IDs whether you want them or not. It is no extra overhead whether you include the ID or whether SQL Server does it for you. I just start the class this way because some of you are not very bright and I got to ease you into this gradually, but now we're on the same page. SQL Server is going to throw those IDs in whether we ask for them or not. When you see a key lookup on an execution plan, one thing that you could do is you could look at the output list. And if they're columns that you use all the time, Stephen is very familiar with this technique. If they're columns that you use all the time, it can make sense to add it over to the other existing index. Now, of course, when you add more columns to the index, that is going to increase the size of the table. More on that later. Hector says ID means the primary key, right? Correct. Yes. And in my mastering classes, I go into situations where it makes sense to have the clustered primary key on other columns, or when it makes sense to do the clustered index as something different than the primary key. But for something like this, for your first class on SQL Server, consider the ID as the primary key clustered index that you always want to use. I did say that sometimes SQL Server does this. In order to get it to do this, I actually had to cheat. I am revealing to you twice inside the span of like 90 seconds that I have lied to you. In order to get this execution plan, I had to use the year 3014. Because if I use the year 2014, SQL Server says, yeah, no, screw the index. It makes more sense just to scan the entire table once. SQL Server has this concept of a tipping point. And the tipping point is the point where it makes more sense to just scan the entire table instead of doing these back and forth key lookups. There is no 1% for the tipping point. Sometimes you'll hear people, it's about 5%, it's about 20%. That is BS. There is no one tipping point percentage, and I prove it there on that blog post. To understand why it makes more sense to scan the entire table instead of use the index, we're going to start by letting SQL Server pick. Then we're going to use an index hint. Now, this is not the first time in this class that you've seen me use index hints. I do not use index hints in production. I think I can count on one hand the number of times in my entire 25-year database career that I have ever left an index hint in place. Don't use index hints when you're getting started because they're very brittle. If anyone changes this index, if someone changes the name, your query can stop working. And I know you think that no one would ever go behind you and change the indexes or tune the indexes or change their names. People are nowhere near as competent, good-smelling, and attractive as you are. You would not believe the herpaderp morons that you work with that will do things like that. So don't leave brittle code like this in place. But it's really useful if I want to just test things quickly to see what the difference is between these two query plans. So the first one, when I let SQL Server choose, versus the second one where I hinted it that I wanted an index seek plus a key lookup. If I hover my mouse over the select in the top one, SQL Server tells me that the table scan cost is about 13 query bucks, whereas the cost of the key lookup plan is about 48 query bucks. This one's way more expensive, and it knew that before the query even started. SQL Server estimated all this before it even pulled rows back. SQL Server had to choose between scanning the entire table and doing the sort, ignoring our indexes, versus using our index. Goodness gracious. Index seek plus key lookup. My wife is cooking something hot. I got to close the door because the vapors are already starting to come up into my office. Holy smokes. My wife likes really hot Chinese food. My wife's from China. They're really, I don't know how this works. There are two different kinds of spices out there. There's Chinese spices, and there's like Mexican or Central American or South American spices. I can handle hot Mexican, Central American, and South American spices. I mean, like I can just nail back jalapenos and stuff like that. I've lived in Mexico for a while. And my wife, on the other hand, cannot handle those. Like even like Rotel dip, she can't handle. On the flip side, Chinese spices, there are some that I just inhale and I immediately go into a coughing fit. And she's like, I don't understand what you're talking about. And she's just downing them left and right. So I don't know how the chemistry on that works, but they are very different kinds of spices. Then there's the Chinese kinds of spices that have numbing, that like numb your mouth. Oh, those are good. I kind of like those. Hero says, China is crazy. I cry every time I go to eat Chinese food. Man, I'm telling you, there's some stuff out there that just, absolutely bananas. So index seeks plus key lookups, they cost more because the key lookup is done for every row that we find. I really hate the way execution plans look. I mean, I like the way that they look, but they need a whole lot of work. One of the things that they need is that you and I see this key lookup down here and we think, oh, this is just one key lookup. But that's not how it works. For every row that comes out of here, we're going to have to look up the key for that row independently. Okay, where's user ID number 14? Okay, now where's user ID number 63? Okay, now where's user ID 1,047,000? This really should be like three-dimensional. It should pop off the page based on the number of times that it was executed. This thing was executed like 149,000 times. It was executed, as Donald says, row by agonizing row, rebar. SQL Server has to figure out how many rows are going to come back from here so that it understands which one makes more sense. Because this is really fast to read 140,000 rows. With each page that we read, we have a bunch of rows on here. We can get all the stuff off of them from one fell swoop. Whereas here, every time we find a row, we have to do a handful of page reads to go find that one row. SQL Server has to make this decision first without looking at the data inside the tables. SQL Server figures this out via something called a cost-based optimizer. Do you remember when you were a kid last week? Do you remember when you were a kid and you had something called a Choose Your Own Adventure book? Choose Your Own Adventure book. This is one that I keep on my desk because someone knew what they were doing when they named that book. The Lost Jewels of Nabuti? I mean, come on, really. And also, I love the fact that it has kind of a bee tree on the back. How cool is that? But so you would read these Choose Your Own Adventure books. You would start at the beginning, and then you would like it say, if you tell them go to the jet, turn to page 19. If you tell them that there must be some mistake and drift off in the crowd, go to page 20. And then the page number that you turned to dictated the ending that you found. Well, you know what you would do when you read these books is you would hit an ending and you'd be like, that ending sucks. I didn't slay the dragon, and I didn't rescue the prince. And I didn't get to the lost jewels in Nabuti. I was dead again, as Simon says. So what you would do is you would go back to the beginning and you would try another ending. You try to do something different. That's exactly how SQL Server's cost-based optimizer works. SQL Server, SQL Dev DBA says, I didn't take my hand off the page, so it doesn't count. So SQL Server's cost-based optimizer gets to the end, one of the endings, and says, okay, looks like this cost is about 16 query bucks. Why don't I go back to the beginning and make some different decisions and try a different ending? So it tries a bunch of different endings in order to find the query that has the cheapest cost altogether. Now, I am simplifying the bejesus out of this. I go into much more details with this on the fundamentals of query tuning and the mastering query tuning classes. The way that SQL Server does all this is it uses statistics. Statistics are one 8K page worth of metadata about the contents of that object. For example, when you go and create an index on last access date and ID, up there, pointed at the wrong thing. When you go create an index on last access date and ID, SQL Server automatically creates a statistic of just one 8K page describing the contents of that index. And then SQL Server uses those 8K pages, those statistics pages, to guess how many rows are going to come back from your query. So when you say things like where last access date is greater than 7/1 of 2014, SQL Server is able to pop open the page of that statistic and say, okay, here's what I know about that index. Here's how many rows I think are going to come back. Throughout this class, I've shown you a few commands. I'm going to show you another command that you can use, totally safe. You can run it in your own session. dbcc show statistics. Whenever I teach something, I want you to understand how often I use it. I don't ever use this. But knowing that it's there helps shape how you work with query tuning. Knowing how SQL Server thinks about these statistics. You're only going to run this a few times. You're going to run this a few times over the next week as you start to understand how SQL Server works. And then you're going to throw it away and you're never going to think about it again. dbcc show statistics is totally safe to run. You pass in first the name of the table and the name of the object that you want to know more about. In this case, I'm passing in the users table and the statistic on last access date and ID. SQL Server says, got it. I'm going to open up that statistic and I'm going to render it to you here on the page. Here's what I know about this statistic. This statistic was last updated in the year 2019. At the time of that, there were about 300,000 rows in this object, and I sampled all of them. SQL Server is exactly like a political pollster. SQL Server doesn't have the time to check with every person to see how they're going to vote. So the larger that your population becomes, the more rows that you have in the table, the more likely it is that SQL Server is just going to sample a small percentage of them to get a rough idea of what the entire table looks like. Sometimes that's accurate, sometimes it's hella inaccurate. Here are the columns that the statistic is on, last access date in this case. And then down here, there's this thing called a histogram. I suck at math in college. I kid you not. I did really well in high school, and then I bombed college math. I mean, I bombed it. I think I got a D on my first one and then Fs for the next 2 semesters. I discovered girls. You would have thought I would have discovered them back in high school. I was too intimidated by that. It turns out I was much better at discovering them in college, and to the point where I couldn't pay attention in any of my classes. Anand says, do select queries create new statistics for the columns? Is that an overhead, especially for large data types? Yes, but the alternative is not knowing anything about the columns that you're querying, and you could imagine how your queries would go then. It's a price worth the cost. So then there's this histogram here. That's just a series of buckets to describe our data. These histograms will look different depending on the data type. For example, over on the left-hand side, there's a statistic on reputation, which is an integer. You can see what the statistics looks like there. Or in the case of a slightly larger data type, display name is a string. For statistic on display name, it gives you a series of buckets saying, for example, Alexander, there are exactly 831 Alexanders. In the range between Alan and Alexander, there are 900 and some rows, and so forth. When SQL Server goes to estimate how many rows are going to come back, it uses statistics on those columns. Like in the case of our last access date query, SQL Server says, well, for me to figure, I always use a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask for directions. He's all, trust me, I got this, when he doesn't really got this. SQL Server says, well, you want to know how many people have a last access date greater than that? I better come up with a rough guess, because I need to guess how much memory I'm going to need in order to sort all these people by last access date. So what it's going to do is it's going to pop open its statistics on last access date. It's going to go pop open that histogram, and it's going to go down to row number, in this case, 56 here. You see how these buckets in the histogram, I have this thing where I want to talk forever. I want to talk forever. And it results in problems with me like not breathing on a regular basis. I get so excited. This is not an act. I get so excited about what's happening in the database that I want to talk forever, and I don't want to take a drink, and I don't want to take a breath. So this is me forcing myself to take a drink. So what SQL Server is going to do is going to go open into this histogram, and you see that series of buckets down the left-hand side. They are not... Oh, Anand says Oracle is a woman. Very confusing. Also expensive. You're the one who said that, not me. Don't blame me for that. So SQL Server is going to go down through that list of buckets there on that histogram. I'm allowed to say that. I'm pansexual. I offend everyone. That is not a joke. SQL Server is going to go through that list of buckets. The buckets aren't the same size. They aren't the same size based on population count. They're not the same size based on date range. It's not like there's a bucket per month. SQL Server is doing the best job it can of painting a picture of our data in just 8K pages. So as a result, these statistics can seem kind of weird. SQL Server is going to go down through that range. It's not like there's a bucket for exactly July the 1st of 2014. SQL Server is going to try to guess how many rows actually match in bucket 56 and then go down and add it up through the rest of those buckets there. That is where babies come from. No, that is where the estimated number of rows come from. Same thing. Estimated number of rows. In this case, SQL Server did a really good job of estimating how many rows we're going to match. That was absolutely amazing because we had stats. The stats weren't sampled, SQL Server read the entire object. There were about 300,000 rows in the object. SQL Server read all of them. Our query was easy to understand. We weren't running any fancy pants calculations on it. But you can think about how, if any of those things are different, our estimate may not be anywhere near as good. It may be much more complicated. And to show you what I mean by that, I'm going to tweak the query. I'm going to look at just 1 month. I'm going to say, show me all the people who accessed the system in July of 2014. There are many ways to write that query, but here's one way, and here's another way. Both of these queries do the same thing in the sense that they produce the same results. Both of these queries produce 728 rows. Look at their shapes. The one on the top used the index plus key lookup. The one on the bottom scanned the table and sorted the rows. There's no sort up here. This one didn't need to do a sort because it used the index, and at the time it read from the index, the data was already sorted by last access date. That's what our index is on. I'm going to go back a slide and show you the queries again. This one used the index. This one did a table scan. So why? This one was really easy to interpret. SQL Server could look at these. They are literals. There are literal strings in here where SQL Server said, right, I'm going to pop open the histogram. I'm going to dive into July the 1st, and I'm going to read until I hit August the 1st. I'm going to know exactly how many rows are going to come up. But for the one that's on a function, for the one that's on year and month. Now, Coda says, is it because SQL Server doesn't have an index on year and month alone? No, because let's think about it. If you and I knew how to do this, we could go to the first date that matched year of 2014 and month of 7. Even if you're not very good at math, and of course I am terrible at math, I still know that that is July the 1st would be the first one that matches. Notice that the estimated number of rows is different. SQL Server doesn't have statistics on the output of these functions, so the estimate is wrong. In the first one, SQL Server accurately estimated that the number of rows would be low, that it would do a limited number of key lookups. But because in this one, it estimated a higher number of rows, SQL Server believed that it would be more efficient to scan the table. To see the overhead of that extra sort, we can turn on things like set statistics IO and time on. When we passed in specific dates, our query read less data and took less CPU time and took less time on the clock. Generally speaking, the simpler your queries are to understand, the better of a job the SQL Server engine is going to do in order to execute it. Now, Rod says, doesn't a function have to evaluate each row to see if it meets the function output? Sure, but it could use the index. I'll prove it to you. Here is when I let SQL Server pick with the function query. Here is where I hinted the index, and I told SQL Server, use the index. This works. SQL Server can do this. In the first one, when I let SQL Server choose, because it had the bad estimate, SQL Server overestimated how many rows would come back, and it scanned the table. Here, the estimate is still wrong, but SQL Server can do this. SQL Server can scan that index, running the function on a row-by-row basis, and only do the key lookups for the rows that match. And it's faster. If I force the index and tell SQL Server, look, I want you to use the index, it ends up doing less 8K page reads and it uses less CPU time because it's not doing the sort. With hinting the index, SQL Server performs better in every way. So why didn't SQL Server choose the index? It all comes back to our estimates and our cost. The table scan cost an estimated 5.8 query bucks, whereas the one with the index cost 6.1 query bucks. Why? Because SQL Server got that estimate wrong. SQL Server thought it was going to have to do a whole bunch of these key lookups when in reality it had to do fewer. That estimate was all driven by our crappy query syntax. It doesn't necessarily mean that SQL Server can't use the index. SQL Server absolutely could use the index, and I showed it to you by hinting it. But if I'm going to give people advice, I want you to write the simplest queries possible in order to get your queries perform as well as possible. But the more you start to pull stunts in there and do things that compile but don't necessarily perform, the worse of a time you're going to have. So to recap what you've learned so far, a key lookup means that the query wanted more columns than we had in the clustered index, or in the non-clustered index. Like when we added display name and age, suddenly SQL Server had to go do that key lookup in order to fetch the additional columns. There's a tipping point where SQL Server believes with enough key lookups that it'll make more sense to just screw the index and do an entire table scan instead. Cost-based optimization is how SQL Server figures out which one of those two choices it's going to make. You can improve your odds with cost-based optimization by writing the simplest queries possible. The simpler your queries are, the easier they are for people to understand, the more likely it is that you're going to get the execution plans that you want. What you're going to read next, what you're going to learn next, is how included columns mitigate those problems, why included columns aren't as cool as people think they are, and then when to consider adding those columns as included. As a reminder, because we're coming up on 90 minutes now, for those of you who need to leave, go head over to brentozar.com/go/engine, where you can get the full version of this session. You're going to learn everything that's in there today, plus more inside the written version of the session as well. Plus, your next step to go to afterwards is my Fundamentals of Index Tuning class. It's a one-day class where I teach you how to design indexes for queries without looking at their execution plans, get the best performance as possible without having to mess around with your queries. Then, after that, your next step will be to go to fundamentals of query tuning. Richard says over in chat, 99% of the time it's not a static date. It's dynamic based on current date or a date stored in another table. Richard, check this out. I have classes for that. I have classes for that. But I can't teach you everything in the first class, because most of the people here, they're not very bright. If they were bright, they would have signed up for my classes long ago. But they're not. They're the kind of morons who herp-a-derp their way through blogs and YouTube, thinking, I'm gonna teach myself and it'll be fine. I jokingly say all the time to people, if you're worried about who your competition is, look at them in the YouTube chat. When you're worried about, I'm not sure if I'm good enough for jobs, look at the people around you in the YouTube chat. Look at the things that they say. Those are your competitors. If you just invest in yourself, do the bare minimum in order to learn more about how this stuff works, attend webcasts, read blogs, read YouTube, or read white papers, things like that, and absorb as much as you can, you will smoke those kinds of morons who They're listening, aren't they? They're listening right now. They won't remember that. we'll go back. All right, so next up, how to think like the engine, where we left off. We had these two queries. We had the one where I had hard-coded in specific date ranges, and then we had some where it was using a function. And the problem that we were having is that because this query got bad estimates, SQL Server was overestimating the number of rows it was going to come back, because SQL Server doesn't have statistics on the output of functions like this. So I said earlier that if you see key lookups, if they're columns that are used all the time, you could promote them up into the index itself. If you hover your mouse over the key lookup and you look at the output list, you could promote those columns up into the index itself. So let's do it. Go to the third page of your PDFs. The third page of your PDFs are what happened when you run this create index statement. Create the index on last access date, ID, display name, and age. Now, one thing that you will notice is that this is a physically larger copy of the table. Now, it's hard to see that just based on one page, but think about this. Look at the number of rows that we can fit on one of these pages versus the number of rows we could fit on this page. This page is much more dense. We can pack in a lot more rows per page, but the more columns that you add, the less rows you can cram in per page. The more columns that you add, the larger your index is going to become. Plus, now we have to keep things in sync with every update as well. But the good news is that now even our badly written query, the one on year and month of last access date, now even our badly written query uses that index. SQL Server is able to use that index and the data is already sorted. There's no sort there inside that copy of the execution plan. So that index does become larger the more columns that you put on it. For example, this is a command from SP Blitz Index. Those of you attending my free class tomorrow on how I use the first responder kit will learn more about how this particular command works. This is a command from our first responder kit called SP Blitz Index that will list out what the indexes are on a table. So here I'm saying, show me all the indexes on the users table. The clustered index, that top line there, it says CXPK, clustered index, the primary key. The clustered index of the table on ID has all the columns on it. So that thing has like all 2.4 million rows in this particular copy of the table. You're looking at about 350 megabytes worth of data. Whereas the one on just ID, or just on last access date and ID, is about 43 megabytes. Then the one on ID last access date ID, display name, and age is physically larger because we can't fit as many rows on each 8K page. The more indexes that you have and the more columns that you have on each index, the more space they take up in memory. And that also means the more competition you have for your existing memory. These pages, they're all fighting for the same space up in RAM. And when you do an insert, when you do delete, SQL Server has to drag all these related 8K pages up into memory. And you can actually end up fighting for memory, having lower page life expectancy, for example, the more indexes that you have. More space they take up on disk, the longer your backups and maintenance takes, the longer your inserts, updates, and deletes take, because we have to lock and update all those copies of the table, the longer your index rebuilds take, statistics takes, and so often. You may have too many indexes if your end users are complaining about slow inserts, updates, and deletes, if your monitoring tools are complaining about blocking and deadlocking, or especially if you're up in the cloud these days, if large database file size is causing a problem. On the flip side, you may not have enough indexes if people are complaining about slow selects Or if you can cache most of the database in memory, that's probably also a sign that you could add more indexes in. For me, most of my clients fall into this category. Most of them fall into the category of people complaining about selects. It's relatively unusual. It's not unheard of, but it's relatively unusual for people to be complaining about blocking, for example. Now, Jeremy says, I just had a case where we had a database with 33% of the database size was entirely unused indexes. It was horrific. Absolutely. You can see it's not unusual at all where you can drop like a third or a quarter of the database size just simply by dropping unused indexes. Immediately your backups, restores, CheckDB, all kinds of stuff can start going faster as you start right-sizing the database. So sometimes you'll hear people say that includes are magically lightweight, that includes make it easier for you to tack columns onto an index, and they don't cost you as much in terms of overhead. Well, let's take a look at that. I've highlighted 2 lines in here. This line says, here's my index that just includes age and display name. Here's the index that's on all 4 columns. There's a musical instrument here, and it's called the sad trombone, sadtrombone.com. Because their pages have the same stuff. I don't understand why people think that includes are somehow magically lightweight. You're including them on the page. There they are. If you want them on the page and you include them, they take up the space. That's how includes work. But the other way that people think includes are somehow better is people will say, well, but when I update those rows, I don't have to move them around. The sort order doesn't really matter on included columns. Oh yeah? Let's find out. Let's pick a row. Sarcastic here. We're going to run an update column that changes Sarcastic's age. We're going to change Sarcastic from 30 to 31. People who believe in includes will say, oh, see, because here now, because it's only included, I don't have to move him around. I could change his age to 99. It doesn't matter. It's just included on the page. It's not sorted. Okay. So what do you think happens when it's part of the key? If age is part of the key and we update Sarcastic to be 31, lick the Butterfinger residue off of your fingers, the Cheetos, whatever it was that you were eating here. Get out your index finger and point on your grimy little monitor to where this person will move to on the 8K page. If I change his age from 30 to 31, where does he move to? Where does his row magically move to? It doesn't move. It doesn't move at all. Because look at the leading columns. The leading columns are so selective or unique. They're so selective that I don't care if his age changes. I don't care if his name changes. Hell, I don't even care if his ID changes. It doesn't change the sort order of the first column. Now, when his last access state changes, that's when we got to pick him up and move him. The first couple of columns in an index are very important. The first couple of columns are going to dictate where this row lays out on disk. But for the rest of them, after the first column or two in an index, I don't really care if you put them in the key or the includes. I am not saying includes are bad. They're fine. They're just not better. They're not better than keys as long as your first couple of columns in an index are fairly selective, are fairly unique. You know what you wouldn't want to put in the first column of an index on a table like users? Deceased. Yes or no. That's not selective. You're not looking for deceased users. Some of you are. You're a little weird. I try not to kink shame, but that's kind of where I draw the line. As long as your queries would all say, like, where deceased equals false, what else are you putting in there? That can't be the only thing that you're looking for. I know that if I ran a dating service, some of y'all would be like, where deceased equals false. That's all I really care about. But for the rest of the time, we're going to put in things like last access date or display name or reputation or whatever it is. Generally speaking, columns that are in the where clause, the group by, the joins, the order bys, those are usually good candidates for your indexing keys. Generally speaking, columns in the select may also need to be added to an index. I just don't want you to think that it's includes or that are going to be magically delicious. Okay, so what we learned in that last sprint there, the less columns that you have on an index, generally the less beneficial that index is going to be. Because most of the time when you write a query, you're usually asking for more than 1 or 2 columns. Generally, the more columns that you have, the larger the index is going to become, but also the larger, more useful it's going to be for select queries. I don't want you to think that included columns are magically free because they still take up just as much space on an 8K page. Hendrik says, I gained a lot of performance by escalating from key lookups to indexes on small tables. Absolutely, yes, totally. That's why I teach it in part of the class too as well. So where to go next? Where you're going to go next, go hit brentozar.com/go/engine, where you can read even more through these slide decks and hit more resource links. The next thing that you're going to go attend is my Fundamentals of Index Tuning class, where I teach you how to write indexes for queries without looking at their execution plans. I show you where SQL Server's missing index recommendations come from, why they're usually wrong. I give you hands-on lab homework that you can do on your own machine to make sure that you mastered the concepts, and then you can dig into fundamentals of query tuning. The good news is that you can learn all of this for free during Fundamentals Week. Fundamentals Week, October 13th through 16th, where I'm going to teach the first half of Fundamentals of Index Tuning, Fundamentals of Query Tuning, Fundamentals of TempDB, and Fundamentals of Column Store. These classes will not be streamed for free on YouTube. You do have to give me your email address for that. You can go register for those over at brentozar.com/go/funweek. If you can't make it to those classes, you can buy the recordings today for even cheaper than our Black Friday sales prices will be. That is all of my fundamentals classes are just $275 for an entire year. Then you can watch them at your leisure. Now, if you buy them, watch them. I know it sounds crazy, but this is like 30 hours, 40 hours worth of classes inside here. You know what happens all the time? Every year, this always happens. People will email me on like October the 1st. And I'm like, Brent, I had a lot of things happen this year. I watched a lot of things on, let's just call it YouTube. I watched a lot of stuff. I didn't really do any training classes. I found TikTok. I went away in the woods for a while. I lost myself. Can you give me another year? I can, but it just has to cost you. Go watch them. Go watch the training classes. Every month, set yourself aside like 4 hours, 8 hours, where you'll actually go through and watch these classes. Because if all you're going to do is buy something and not watch it, tell yourself that you bought YouTube. Because there's a ton of stuff on there that you and I will never see because there's so much crap. It's just absolutely terrible. brentozar.com/go/early Black Friday will get you the recordings of all my fundamentals for an entire year for $275. Now, I'll pop over here. So Hero says, how do I convince my manager to buy it? I need a course on persuasion. Oh, I should use this other display here so that you can see Hero Relax's question. Hero Relax, here's the way that I would say it, is I would walk, and this is true. At first it's going to sound like I'm trolling, but this is exactly how I would do it. I would walk into my boss's office and say, look, over the last couple of years, I've learned as much as I can from free resources. I kind of feel like I've hit the wall from the free resources out there. I've exhausted Brent Ozar stuff. I've gone through YouTube. I've even tried watching porn. I'm out of the free stuff. It's time for me to start watching some of the paid stuff because I'm hitting more advanced problems now. Your boss is going to be like, what kind of porn did you watch? Actually, I'm not sure that I want to know the answer to that. But say that you've exhausted the free resources first. That's one of the best ways to go at it. And then give them specific examples of, here are things that I'm unable to do that I need to be, or things that take me a really long time that are in his class as, here's how I'm going to teach you, or what I'm going to teach you to do. I like that approach so much longer than, or so much better than saying I want to get a certification, because bosses often don't care about certifications. Makes it much easier. SQL Dev DBA says how to ask your boss for training money is a great article by Mr. Ozar. That's true. I should have a link in there too as well on it. I don't know about y'all, but I know that I will never forget the first time that my boss actually paid for training for me when I was a database administrator. There was an ad came out for a conference, and I went to my boss and I was like, hey, here's this conference, just so you know, it's in these dates. I'm like, I don't expect to be able to go, but just here it is. And my boss was like, okay, sure. Go check, see how much hotels and flights are, and give me a number for what the whole thing will be with you, like having meals. And I was like, what? I was like, is that easy? And he's like, well, no, it's not that easy, but it's my job as a manager to go try and fight for the training budget. He's like, it doesn't really cost me anything extra. It's the company that has to decide. Well, it's not like it's coming out of my pocket. He says, I'm just going to go to human resources and ask them and see if they'll do it. And he actually did it. It was an absolutely great boss. I love him. Don Duncan was one of my favorite bosses. You don't know how good your boss is about that stuff until you ask. And if you ask and they say no, that's also your sign that you probably want to look for a job. Now, not necessarily as urgent. The time to look for a job is when you actually have one. The time to look for a job isn't when you're laid off. The time to look for a job is when you actually have one that you're vaguely comfortable with. Right now, it seems kind of scary because you hear about all these layoffs and you hear about AI taking jobs and stuff like that. If you have a job, you should at least be looking, because great jobs pop open all the time. And you want to be negotiating from a place of comfort. You want to be able to say, I'm just going to pick a round number because it's easy. Let's say you're making $100,000 a year right now in whatever your chosen currency is. Say you're making $100,000 right now. You want to talk to recruiters or job positions, and when they ask you what salary you want, you can say, well, I'm making $100,000 a year right now. What it would take to get me was, say, $140,000. And they'll start negotiating with you or whatever. And you can be like, no, the only way that I would leave is for 140. And I'm just making this number up. You have to decide what's good for you. But then at least that way, everybody's on the same page. And if they give you the interview, if you get an interview for that, you know that you're already on their radar as being worth that much. And if they say no, or they try to lowball you, that's fine. You have a job. Whereas I tell you what, once you don't have a job, once you've been laid off, it's you negotiate from a much worse place. You take way less money just in order to get your mortgage paid or whatever, and then you're going to be wanting to flip to another job really quickly, and you're going to have a hard time. EE says, will the H-1B thing affect DBA hiring? Yes, absolutely. For those of you who are in the United States, the current administration just set the H-1B visa prices to $100,000 per employee per year, $300,000 for 3 years. And that will absolutely affect DBA hiring. You're going to hear people say, no, it's going to promote outsourcing. That's not true. Here's why. Any DBA role that could have been outsourced has been outsourced. Outsourcing is not new. Outsourcing is as old as time itself. Companies have been trying to outsource for a really long time. What it's going to do is the companies who still insist on having people in person inside their country's borders are going to suddenly be like, oh my God, I used to be able to get H-1Bs for $50,000 a year. Now it's going to cost me $150,000 a year. It's going to escalate salaries for U.S. onshore employees. Rudy says, what about remote DBAs? It affects a lot depending on which country you're in versus what country your remote DBA job is in. But if you're in the United States, then that's a totally different matter altogether. Georgie says, will AI replace DBA jobs in the future? I think it's quite realistic. Georgie, I'll tell you something. AI is going to replace some of the people in this chat. But a warm vacuum cleaner could replace some of the people in this chat. A dead cat could replace some of the people in this chat. Those are the ones whose jobs AI is going to take. You know which ones we're talking about. Simon says, I've paid for the fundamentals and mastering classes first time around, self-funded, their weight in gold, paid for themselves 100 times over. Woohoo! That's fantastic to hear. Well, we had relatively few questions this time around, and I was, I guess, kind of polished. So at less than 2 hours, we're going to call it quits here because we made it through the entire class, which is actually awesome because today my iPhone Air arrives. I got a text this morning from Apple saying that it was out for delivery sometime between noon and 2 p.m. And so I can't wait to unbox that thing. I am so excited for it. I am the perfect kind of customer for that. I love those really thin phones. So thanks for hanging out with me. Tomorrow we will be doing how to use the first responder kit. Thanks, y'all, and I will see y'all tomorrow. Adios.